So in this video, I will explain one problem on the analysis of simple truss by method of section. Before moving on to the numerical problem, first I'll give you the brief about the notation of compression and the tension. We all know that a compression is nothing but if member is there, if I apply the inward force, it will be compression, right? So whereas in the tension, it will be a pulling force, outward force. So that will be called as the tension, correct? So this is known as a tension and this is known as compression. Okay? But whereas in the member, when we are showing the direction for the tension and the compression, so you have to keep in mind that the externally tension will be internally compression. That means if I draw this direction, this will be tension, okay? But whereas in the member internally, I have to draw the inward forces. So this shows the tension, okay? So if I want to draw the tension, then I have to draw the inward forces. If I want to draw the compression forces, then I have to draw the outward forces in a member. So this will represent as a compression. So internally tension, externally compression, externally tension, internally compression. It's a reverse way. So if I want to make the member compression member, then in a truss, a compression member is nothing but outward force. Tension member is nothing but inward force. But externally, it's a reverse. Inward force is a compression, outward force is a tension, correct? So this is the concept behind this. Or else what you can do is, just for the simple concept, always take the force or the direction of the force away from the joint. Away from the joint is nothing but a tension, okay? Away from the joint is nothing but tension. Here what we are doing is, we are assuming all the forces are tension. So tension forces will be considered as a member in all the member, okay? So what I'll do, I'll consider all the forces as a tension member. It will be easy for us to solve the numerical, okay? So all forces will assume it as a tension. If we get the answer what we have assumed direction, that means positive value, then it is tension member. If we got the member as a compression, that is negative value, then member is called as a compression. Clear with this? So away from the joint will be considered as a tension member. For now you remember this, okay? Start with the problem. Determine the force in a member of BC, BG, EG and GD of a truss shown in figure. So we need to find out the value of BC, this member we have to find it, BG, this member we have to find it, EG, this member we have to find it, GD and this member we have to find the value. So whereas in the joint method, generally we'll consider one joint and we'll solve it. But whereas in this section, we'll cut this section along the direction of along the members which we want to calculate the member forces. In this case, we have to calculate the member forces BC, BG and G. So what I'll do, I'll just draw a section line towards this. And one more thing, if you are drawing a section line, the section line has to cut from one end to the other end. You cannot restrict between this only. It has to pass out from inward to outward, from start to end. It will not stop somewhere in between this one, okay? So for finding out the EG, BG and BC force, I'll cut this section along this side. So if I cut the section, the free body diagram for this will be like this. So what we'll get? So this is the force. So we have cut this section, we have cut this section, and we have cut this section, okay? So this force I'll write FEG. For this BG, so I'll write FBG. For this I'll write FBC, okay? So other than this, what we have a load of 60 kilonewton and there's a support reaction, correct? This is the free body diagram what we get, okay? So after drawing the free body diagram, we have to calculate the angle for this. What will be angle? So angle can be calculated. So this theta will be, so we know that this height is a 3 meter and this width is 4 meter. If I take it a triangle, which has 3 meter height, 4 meter this, and this is theta. So tan theta is equal to 3 by 4. So theta will be tan inverse of 3 by 4. So theta will get 36.57 degree. So the theta will be 36.57 degree. So right, 36.57. Okay. So we have calculated the free body diagram, but one more thing we are missing here. We have to calculate the reaction first. Okay. For the calculation of the reaction, how many reaction we'll get? So see, there's a one reaction because of roller cell, right? RA. Here we'll get two reaction. One is here RCY and RCX. So we have to calculate this. So for now, I'll remove this part and this free body diagram also. First we'll calculate the reaction, then we'll draw one more time free body diagram. Okay. So for the calculation of the reaction, so first I'll go with the summation of Fx equal to 0. So how many horizontal forces we have? So while considering the reaction, see that only you have to consider the external force and the external reaction, not considering the member forces. If I take that, so it will be a plain truss which consists of one reaction which is RA. Here we have RCY and here we have RCX, and there's a load of 20 here, 60 kilonewton load, 60 kilonewton load. Okay, so the angle for this is given as a 53.13. I have missed it over here. Okay, this angle is 53.13. Okay, this for this truss we have to calculate the reaction. Okay, so only you have to consider external forces and the reaction. So start with the summation of Fx. If I take it summation of Fx equal to 0, so we have one horizontal force, and then we have to resolve this, which is 20 cos of 53.13, 20 sine of 53.13. So in the summation of Fx, we'll get two forces, which is RCX moving left side, so minus, then plus 20 cos of 53.13, which is equal to 0. So if I take RCX will be equal to 12 kilonewton. 20 cos 53.13 will get 12 kilonewton. So this we got one value. Then I'll take this summation of, instead of y, first I'll get summation of MA. Okay, so if I take the summation of MA, then I have to take the moment at this point. So this is the 4 meter, this is the 4 meter, and this is the 4 meter, and the height is 3 meter. So if I calculate the moment, so moment due to RA will be 0, moment due to 60 will be a clockwise direction, 60 into 4. Then again there is one more force which is again acting in downward, so if I apply the force, then it will be clockwise direction, so plus 60 into perpendicular distance will be 8. Then this force, so 20 sine 53.13, I'm acting upward, so it will create a anti-clockwise movement, so minus 20 sine 53.13, okay, into the distance is 444, so that will be a 12 meter. Okay, then come to this force, RCY moving upward, so it will create an anti-clockwise movement, so minus RCY into 8, and moment due to RCX will be 0, 20 cos 53.13 as well 0, because the line of action of force passing through the moment center, so it will be 0, so it will, so that is equal to summation of M equal to 0. So I'll get this. If I simplify this, what I'll get, RCY will be equal to 66 kilonewton. If you calculate, keep RCY into other side, so remaining, if you take 16 to 4 plus 16 to 8 minus 20 sine 53.13 into 12, so we'll get some value. If you divide with the 8, so I'll get 66 kilonewton. Okay, so similarly, if I calculate the summation of Fy equal to 0, so how many vertical forces? 1 2 3 4 5. So I'll get RA, which is moving upward, minus 60 which is moving downward, again the second force which is minus 60, then 20 sine 53.3 equal to 0. So then RA will be, if I take 20 sine 53.13 on the other side, minus 60 on the side and minus 60 on the other side, so it will be 60 plus 60 minus 20 sine 53.13, so that will be equal to 38 kilonewton. So these are the reaction what we'll get. RA as a 38 kilonewton, RCX as 12 kilonewton, RCY as a 66 kilonewton. These are the reaction what will get with this. Okay, so after the calculation of the reaction, we have to calculate the member forces. For doing that, so I'll rub this part. So now as earlier I told about the free body diagram, again I'll draw one more time that free body diagram. So the section is cutting at this level to calculate the reaction member forces FBC, FBG and FEG. Okay, even we have calculated the angle for that. What we got angle is 36.57, and the reaction already we have calculated RA, which is nothing but 38. Then there's a load is acting which is of 60 kilonewton. Okay, so these are the this is your free body diagram. Now what we have to do is we have to use the summation of fx equal to 0, summation of fy equal to 0, summation of m equal to 0 to get the member forces, the condition of equilibrium, equation of equilibrium. So for doing that, what I'll do first, I'll consider the for this free body diagram summation of fy equal to 0. So in this case, how many vertical forces we have? 1, 2 and this, if I resolve it to the vertical one. So what I'll get, RA which is moving upward, so I'll take it as a 38, then 60 kilometer is moving downward, so minus 60. Then if I resolve this, then it will be FBG sine 36.57, so moving upward, so plus FBG sine 36.57 equal to 0. If I solve it, so the FBG value what I'll get is 36.667. See, the value what we are getting is positive. That means what number we have assumed is a tension. So if the value is positive, the assumed number is tension itself. So I'll write T value. If it is getting negative, then the assumed number is tension, but what we are getting negative of that. That means it's a compression member. So in this case, we are getting the positive value. So we have taken as a T as a tension. Now come to the second condition, which is summation of fx equal to 0. Summation of fx equal to 0. If I take the summation of fx equal to 0, how many horizontal forces we have? 1, 2 and 3. This will create a horizontal component as FBG cos 36.56, FBC and FEG. So in this case, if I take it, two member will be unknown. So instead of summation of fx, I'll go with the summation of m first. Movement I'll take first, then I'll go for the summation of fx. So it will be summation of m. At this point, I'll take the moment I've taken summation and solved with the summation on d. So I'll go ahead with that itself. So moment due to the FBC will be 0. Moment due to FBG is 0. Only remain with the 38. Then FEG, because 60 also the line of action of force passing through the moment center. This also will be 0. So start with your first force, which is 38. It will create a clockwise movement because you are acting upward. If I apply the force to the member, it will move in a clockwise manner. So it will be 38 into the distance will be how much? This distance is already we know that, which is 4 meter. 38 into 4, which create a clockwise movement. Now come to the FEG force, which is acting in this direction. So it will also create a clockwise movement. So positive FBG into the distance height is, we know that, which is 3 meter equal to 0. So if I calculate, so FBG, it's a FEG. So I'll get FEG value as a 38.4. If I take it on the other side, so it will be minus value and divide with a 3. So I'll get FEG as a minus 50.667. See, in this case, the value what we are getting is minus. That indicate that we have assumed number is a tension, but the value what we are getting is negative. That means it is a opposite of the assumed number. So it's a compression member. Okay. So if you get the negative value, you have to use the C. That is a compression member. Similarly, calculate your summation of Fy to get the other value, which is FBG value. Sorry, summation of Fx here, not Fy. Already we have calculated the Fy. Okay. If I calculate the summation of Fx, how many horizontal forces I'll get? FBC and FBG and FEG. So first I'll start with the FEG, which is moving right side. So FEG positive plus FBC, then plus FBG cos of 36.57. All the values are moving right side, so we'll get this one. So if I simplify this, and then I'll get FEG value is minus 50.667 plus FBC, then plus FBG, what we got is 36.667 cos of 36.57 equal to 0. If I calculate, FBC will be, I'll get so 50, and if I do it, so I'll get 21.33, which is nothing but positive value is nothing but a tension. If I get the positive value, then it will be tension. Okay, cross check one more time. So 36.667 into cos of 36.57 will get 29. So minus 50 will be, so if I take it on the side, it will be so positive. Okay, correct. So we have calculated the FBC value, FBG value and FEG value. So only remain with the FGD value. So FGD is nothing but this member. So what I'll do, I'll draw the section along this direction, so that I will cut the member. So if I cut this section, then I'll get the free body diagram like this. So this is FCD, this is 20 kilonewton, and this is FDG or FGD. So this force we have to calculate. So angle for this, even this angle will be remain same, because this is 3 meter and this is 4 meter. Tan inverse of 3 by 4 will get 36.56 itself. So angle will be 36.57. Okay. So this is what we get. Okay. So what I can do is I can use the summation of Fy equal to 0 to get the value. If I take the summation of Fy equal to 0, then I'll get FDG sine 36.57 plus 20 sine 53.13. If I simplify, equal to 0. If I simplify, then I'll get FDG as a minus 26.67. So if you are getting minus 26.67, that is a compression. Okay, that is your method of section. Hope you are clear. Okay, if you have any doubt, you can ask me through WhatsApp message. Okay.